Example 4. When the boundaries of the function can change. So in example 4, we're going to determine the area of the region R in the first quadrant, bounded above by y equals the square root of x, and below by the x-axis and y equals x minus 2. So if you graph all of these on your graphing calculator or graph them by hand, you'll get a graph that looks something like this. And so on this graph, you'll notice that if you were to do the integral of the square root of x minus 2 minus x, you would get this extra piece as well that we don't want. So the technique we're going to use to solve this problem is we're going to break this integral into two pieces. The first piece is going to be the integral from the square root of x all the way until we get to the function, because this is a nice piece right here. And then we're going to find the integral of this shaded region. So we're going to break up our integral into two sections and then add them together. So take a second and make sure you have this graph drawn on your piece of paper, where the top function is y equals the square root of x. This is y equals x minus 2. And this point right here is 2, 0. And we're going to call this first region A1, and we're going to call the second region A2. And so if we want to find the area of the entire region, you find the area of the first region and add it to the second region. Now this graph is kind of easy to see where our x value should be to break it up, but I'm going to show you actually how to evaluate if it's not so easy to see by just looking at the graph. So what you do is I want to figure out first where this point is, the 2, 0. Well, that's where the line y equals 0, which is the line across the x-axis, and the equation y equals x minus 2 intersect. So to find that, you just set it equal to each other. So 0 is equal to x minus 2, so x is equal to 2. That's where that comes from. Now what we have to do is figure out this ending point. Now we can see just from the graph it's 4, 2, but again, I want to show you algebraically how to find it. So we have y is equal to the square root of x, and y is equal to x minus 2. So what we need to do here is set them equal to each other. So you get the square root of x is equal to x minus 2. And then we square both sides. So we get x is equal to x squared minus 4x plus 4. So 0 is equal to x squared minus 5x plus 4. And then you factor this. So you get x is equal to 4 and x is equal to 1. Well, we know this is going to be our value, and the way we know it's not 1 is we plug it back into the equation to check solutions. Remember from Algebra 2, whenever you square both sides, you might get extraneous solutions. So if you plug 1 in, you get the square root of 1 is equal to 1 minus 2, negative 1, and that's not true. So this is what we call extraneous. That's where the x equals 2 and x equals 4 comes from. All right, now we're going to integrate to find the area of the first part and the area of the second. So the area of the first part is going to be the integral from 0 to 2 of the square root of x dx. Because since we're trying to find this, it's just the area under the square root of x curve. So this is 0 to 2, x to the 1/2 dx. And then when we integrate this, we're going to get 2/3 x to the 3/2 from 0 to 2. So we get 2/3 2 to the 3/2. And remember what 2 to the 3/2 means. That means either you cube it and then take the square root, or you take the square root and then cube it. So you get 2/3 times the square root of 8, which is 2/3 times 2 root 2, which will give us 4 root 2 over 3. Now we need to find the area of the second region. So the area of the second region is going to be all of this area in here. So this is going to be the integral from 2 to 4, because those are our x values. And then our top function is the square root of x, subtract our bottom function, which is x minus 2, dx. So this becomes the integral from 2 to 4, x to the 1/2 minus x plus 2, dx. And so now we're going to integrate. So when you work that out, you'll get 10 over 3 minus 4 square root of 2 divided by 3. And so now, to find our final answer, it's going to be the area of the region is equal to area 1 plus area 2. And recall that area 1 was equal to 4 root 2 over 3. Plus area 2, which is 10/3 minus 4 root 2 over 3. So these are going to cancel. And our area is simply 10/3 units squared. And that's how you solve it. On your own now, I want you to determine the area enclosed by the region y equals x, y equals 1, and y equals x squared divided by 9. If you get stuck, this graph may help. However, on a test, you're going to be required to make this graph on your own. Okay, so looking at this graph, we can see we need to break this up into two pieces. You see how we have a function here, which is our upper bound, and then the upper bound right here, it changes, which means that we're going to segment it where the upper bound changes. So our first integral is going to be this area, and our second integral is going to be this area. So it helps me personally, and probably you, to diagram and then label everything. So this is y equals x. This is y equals 1. The blue one right here, this is y equals x squared over 9. I'm going to call this region 1. I'm going to call this region 2. And then we need to figure out what these coordinates are. I need to find out that coordinate. And this one's obvious. This is 0, 0. So our total area is going to be area 1 plus area 2. The first thing we need to do is determine all of these points. So we have to find the first point, y equals x, and y equals 1. So this one's kind of easy. X is simply equal to 1. So we get the coordinate 1, 1 here. I don't really need the y coordinate, I just need the x coordinate. And now let's talk about how to determine this point right here. We're going to set y equals 1 and y equals x squared over 9 equal to each other. So you get 1 equals x squared over 9. 9 is equal to x squared. X is equal to plus or minus 3. But since we're in the first quadrant, our x value is only 3. So this is 3. And if you plug 3 in, you will get 1. Okay? So now let's go ahead and evaluate our integrals. Area 1 is going to be the integral from 0 to 1 of our function here, which is x. And we're going to subtract our bottom function, which is x squared over 9. And then we just need to integrate. So this becomes 1/2 x squared minus, and this is 1/9 divided by 3, so you get 1 over 27 times x cubed from 0 to 1. So this becomes 1/2 times 1 squared minus 1 over 27, 1 cubed. And I get 1/2 minus 1 over 27. And now finding common denominators, I'm going to get 27 over 54 minus 2 over 54, which leaves me with 25 over 54. Now I need to find the area of region 2. And this is going to be the integral. Looking back up here, we see we're starting at 1, and we're going to integrate all the way until you get to x equals 3. So from 1 to 3. And our top function is y equals 1. And our bottom function is still x squared over 9. So this becomes x minus 1 over 27x cubed from 1 to 3. And then this is going to be 3 minus 1 over 27, 3 cubed, minus 1 over 27, 1 cubed. So this gives me 3 minus 3 cubed is 27, and 27 divided by 27 is 1, minus 1 over 27, which is going to be 2 minus 1 plus 1 over 27, 1 plus 1 over 27, which is going to give me 28 27ths. So now what I have to do is add those two numbers up, because the area of my entire region is area 1 plus area 2. So this is going to be 25 over 54 plus 28 over 27. So this is 25 over 54 plus 56 over 54, which gives us 81 over 54. And you divide those both by 27, and you get 3/2 units squared. Now, yes, I know I could have just plugged that into a calculator and got a decimal, but I want an exact answer, and sometimes when you use the calculator to solve it, it'll round it.